Hello, everybody. It is Mr. Odom, and today I am going to go over the high points of Chapter 13. So there's quite a few problems here, extra problems if you want to work on them. The answer key will be at the bottom, so I'll stop the video down there so you can see the answers. And you can rewind the video and go back and work out problems that I haven't worked out. I worked out a couple, but I saved most of them for you to work out. So you have extra practice. Okay. So let's get started with this review. All right. Let's scroll down. Oh, I recommend that you work out these problems, okay, in your composition books. Okay. That way you have a little more extra practice in trying to find slopes and graph equations and write linear equations in slope-intercept form and so on. All right, key vocabulary. You should be comfortable with what all these different words or phrases mean. And if you forget, the page number in your online textbook, which you can get to, has the definitions for all of these different vocabulary words or phrases. All right, let's get started. So in section 13.1, what did we do? We learned how to graph linear equations. And how did we do that? Well, if you look at a table, if you're given a linear equation, you can make a table. And what you do is you make some values for x, you put them into the equation for the line, and you figure out what the y coordinate is. So you start with the x coordinate, put that value into the equation, and then out comes the y coordinate. And then you have a pair of x and y coordinates, which you can plot on a graph, which you see below. Okay, plot the points, draw a line through it, you're good to go. So I graphed a few of these on here. Number one, y equals 3/5 x. So how did I do that? Well, I can make a table. So I can say x and y. I could do it this way. And here's my equation. Y equals 3/5 x. So 0 is always a good number I choose for x. So when I put 0 into this equation, 3/5 times 0 is 0. Okay. What if I put 5 into the equation? Okay. So when x is 5, I have 3/5 times 5, and you guys can do that math and see that the 5's cancel, and you'll have y equals 3. All right. What if I put -5 into this equation? I'll end up with -3. So there's 3 good points, and you can see here's -5, -3. I didn't plot that point, but there it is. I put 0, 0 on there, and I plotted the point 5, 3, and drew a line through it. Okay. I also remember that horizontal lines have a certain form, y equals -2. So it follows the form y equals b. Okay. And then for number 6, I remember the vertical lines follow the form x equals a, where a and b are just integers or rational numbers. Okay. So I left a few for you to practice. You can draw your tables like this in your composition book and work them out and then graph them. 13.2, what did we do? We talked about what is a slope, and we have this equation for slope, and hopefully you have it written somewhere in your composition book. Slope equals y sub 2 minus y sub 1, which is the change in y, also known as the rise, divided by x sub 2 minus x sub 1, which is how does x change on the line, and that is also known as the run. So remember, slope is the rise over the run. Okay, that's how I kind of remember it. So here's an example. Oh, you can see the example here. You want to find the slope of each one of these lines. And this is a good way to show, like the green line, that the green line is a horizontal line. Okay, And then what happens? The slope for all horizontal lines is 0. And you can see from the math, the numerator, 4 minus 4. You'll get that every time when you graph a horizontal line, the numerator will be 0. For the red line, we see that the denominator is 0. Remember, we said for vertical lines, slope is undefined. And then for the blue line, again, labeling your values. This is what I do. X sub 1, Y sub 1, X sub 2, Y sub 2 is always a good habit, and it will help you keep the values in order when you put them into the equations. And so that's what I recommend you do. So that's what I did down here. Here's a table, and all I did was pick 2 different X and Y pairs or coordinates, and I labeled them X sub 1, Y sub 1, X sub 2, Y sub 2, and I used the formula for slope. And you can see the steps that I took to get the slope equals 1. So I saved the other 2 problems for you. Graphing proportional relationships. Okay, remember, slope. The slope is a unit cost or a unit rate. Okay, so that's important. Slope, the slope of a line, is a unit rate. Okay, put some stuff on there. There you go. Slope is a unit rate. Don't forget that. It's important. And that can help you when you want to interpret graphs. So here's number 11. Studying the number of hours, Y hours, which means what? It means that hours is your units for the Y axis. Okay. And then you study after X days. So what does that mean? It means that your units for the X axis are days. And it's represented by this equation. The number of Y hours that you study after X days is represented by this equation. Y equals 1.5x. Or I can write it like this, 1.5x. And the reason I do that, why am I doing that? Because then I can turn my mixed number into an improper fraction. Why do I want to do that? Because then it helps me to graph the equation of the line. Because I can use 3/2. I can say, well, now I know what my rise is, and I know what my run is. So the bottom line is when you have a decimal, okay, turn it into an improper fraction. So that way you can see what the rise and the run are. All right. I know that this line is proportional because if I let x equal 0, y equals 0, and that line passes through the origin. All right. So it passes through the origin, and then I can rise 3, run 2, rise 3, run 2. And then I can graph my line. So, and what does the slope mean? Okay. Remember the equation y equals mx. This is for a proportional relationship. If I divide both sides by x, which I can do using the division property of equality to get m all by itself, I see that y over x equals m, my slope, which means that my slope is 1.5 hours in one day or per day. And what does that mean? Well, I'm studying, right? I'm studying. And it says basically that I am studying 1.5 hours per day. That's what the slope means in this problem. Okay, so remember that when you're on your test, if you have to interpret the slope, okay, think about the slope as a unit rate, and that should hopefully help you to make sense of it. All right, 13.4, graphing linear equations in slope-intercept form. I had you write down slope-intercept form. Remember that form is y equals the slope times x plus B, and B is the y coordinate of the y-intercept. Okay, so if you want to graph an equation, y equals 0.5x minus 3, you can find the slope. The slope is 1/2, right? You can see that right here. 0.5 is the same as 1/2. So I can have, there's my rise is 1 and my run is 2. So I start at my y-intercept, and notice how I did my rise of 1 and my run of 2, and I could plot another point. And then I just extend that line and see where does it cross the x-intercept. The x-intercept is where y equals 0. Okay? And so you can see that the line crosses the x-axis at this point. So the intercept, the x-intercept is 6. Okay? So here I graphed an equation. I did number 12, so because I knew that would fit on my graph. So I graphed it. I have my slope. My rise is 2. My run will be 1. I see where my y-intercept is, so I graph it. Now, where does this graph pass the x-intercept? You can see it crosses it right here at this point right here. And what are the coordinates of that point? The coordinates of that point are x is 3 and y is 0. So that is my x-intercept. Okay, my x-intercept is this coordinate, and it is a, remember a represents the x-intercept, so a equals 3. Okay, so that's it. You guys hopefully can do that, and you have examples. You got that example, and you got that one. All right. 13.5, graphing linear equations in standard form. Remember standard form, ax plus by equals c. And a, b, and c are just numbers, and x and y are your variables. So one way to do this is write the equation in slope-intercept form, which means you get y by itself. So notice how they did the math here. And once you do that, you can see what the slope is. The slope is -2, and the y-intercept is at the point 0, 4. Okay, so you can graph it. Here's your y-intercept coordinate right there. And then your rise is -2, and your run is +1. And so you can go ahead and graph another point and then connect them, and then you have the graph of the equation 8x plus 4y equals 16. Another way to do it is to find the x and y intercepts. So here's what I did for problem 16. Let me scroll back up so you can see here are the problems. So I worked out problem 16 down here. So we have -4x plus 2y equals 8. Well, the y-intercept is where x equals 0. So I just plug that into my equation. I figure out what y equals. Y equals 4. So now I have a point 0, 4. I do the same thing to find the x-intercept. The x-intercept is where y equals 0. And so I plug that into the equation, and I end up with x equals -2. So here are my x-intercepts and y-intercepts. So I plot those points. I draw a line through those 2 points, and you can see the equation of the line. If I wanted to, I could write this equation in slope-intercept form. So let me just do that down here. How do I do that? Let's see, 2y equals 8. I want to get y all by itself. So I need to add 4x to both sides. And then that leaves me with 2y equals 4x plus 8. I divide both sides by 2, which is on the right side, means I can divide each term by 2. Over here, that gets y all by itself. and I end up with y equals 2x plus 4. And you can see that my y-intercept here is at the point 0, 4. And then my slope is a rise of 2, so I can rise 2. So from here I go up 2, and then I run 1. I can go up 2 again, and I run 1 again. And you can see that these two equations, this one, y equals 2x plus 4, and the original one, negative 4x plus 2y equal 8, represent the same line. Okay, there you go. Let's look at 13.6. Here we have the slope-intercept form, or y minus y sub 1 equals the slope m times x minus x sub 1. Okay, so wait, I just made a mistake. That's not what I wanted to do. Yeah, I just got ahead of myself. So we want to write equations in slope-intercept form. What does that mean? That means if you're given a graph of a line, here are my 2 points, okay? So I can find the slope. So this is what we do. We find the slope, which we use the formula for slope. We plug in our values, and we get the slope equals 1. And we see here at this point where the line crosses the y-axis that b equals 2. So I can write my equation for the line with my slope and my y-intercept. And you end up with y equals x plus 2. All right. So let's do another one. So here again, I see this line that goes through this point. So I know b for my y-intercept, b equals negative 2. And I just have to calculate my slope. And you see you have to go through, use the formula, make sure you label your coordinates correctly. And I have a slope of negative 2/3. So the equation is going to be, here's my slope, my y-intercept. You plug them in, and you get y equals negative 2/3 x minus 2. So I worked out one. I did number 24. Here is my coordinates for number 24. They are 0, 8, and 6, 8. And I labeled them. So what did I do? I calculated my slope. My slope was 0, which means this is going to be a horizontal line, right? I already know that. Whenever I have a slope of 0, I have a horizontal line. So just to prove that, I write down the slope-intercept form. I plug in what I know. I see here my y-intercept. B here is 8. And I end up with the equation y equals 8, which is a horizontal line. All right. And finally, 13.7. Now we get to point slope form. Now I can write down this equation. I guess I was just super excited about it. Sorry. It's written down. It's right here. Y minus y sub 1 equals the slope times x minus x sub 1. So what do we have to do? Well, it says write in slope-intercept form an equation of a line that passes through these 2 points. So first, I know how to find the slope, right? I'm not going to go through that again. You guys calculate the slope. You got it. And then I just pick one of these 2 points. And it doesn't matter which one you pick. Let's say I labeled this one as x sub 1 and y sub 1. Then I would use this point. But if you guys labeled this one as x sub 1 and y sub 1, you could go through this math down here just like they did, and you would get the same answer. So basically you plug in the y coordinate and the x coordinate, and you basically write the equation in slope-intercept form, okay? So that's what we end up doing here. And I did an example. So 27, again, I labeled my points with x sub 1, y sub 1, x sub 2, y sub 2 to help me to calculate my slope. And then I use the point slope form, and I use the points -4 and 2. So there I put my 2 in, there's my -4. I clean this up a little bit. That's x minus -4 is the same as x plus 4. So I clean that up a little bit. And then I add 2 to both sides. And I see here that I have subtracting 2, then I add 2. So this side is just 0. And I end up with the equation y equals -1/2. And I totally forgot to write the x. Okay, whoops, that's not what I wanted to do, sorry. Y equals -1/2 x. All right, so kind of a long video. There are some of the answers, so I'll leave those there. So if you want to pause the video so you can see the answers to problems 1 through 11. And then I'm going to scroll down so you can see the answers to problems 12 through 17. And then I'm going to scroll down so you can see the answers to problems 18 to 27. And I will stop the video here. Sorry, it's a longer video, but it's quite a bit to get through. Hope everybody's doing well. This is Mr. Odom, and I am OUT.